Good morning, all. Today we are going to study four-stroke petrol engine using a cut section model. In a four-stroke uh, engine, the cycle of operation is completed in four stroke of piston or two complete revolution of crankshaft. During these four-stroke, five events needs to be completed: suction, compression, combustion and expansion, and finally the exhaust. Each stroke consists of 180 degree of crankshaft revolution, and hence a four-stroke is completed through 720 degree of crankshaft revolution. The cycle of operation for an ideal four-stroke SI engine consists of suction, compression, expansion of power stroke, and exhaust stroke. Let's see these four strokes in detail. The first one is intake or induction. You can also call it as a suction stroke. During this, the piston travels from top dead center to bottom dead center with the intake valve open and exhaust valve closed. This opening of the valve creates an increase in volume in combustion chamber, which in turn creates a vacuum. Due to this, the pressure inside the chamber is different and outside pressure is different. This resulting pressure differential through the intake system from atmospheric pressure on the outside causes the air to be pushed inside the cylinder. As this air passes through the intake system, the fuel is added to it in the desired amount to create proper proportion of air and fuel mixture by means of a fuel injector or carburetor, and finally this air fuel mixture enters into our combustion chamber as a working fluid. So this is the first stroke in four-stroke SI engine. The second one is our compression stroke. In this, when the piston reaches bottom dead center, the intake valve closes. Also, the exhaust valve is also closed during this stage. The piston will now travel from bottom dead center to top dead center with both the valve closed. As the piston moves, it goes on compressing the working fluid or the air fuel mixture which have been taken during the intake stroke, due to which both the pressure and temperature inside the engine cylinder rises. Now, there will be some time interval required for the closing of intake valve, which means that the actual compression doesn't start until some time after BDC. When it will start? It will start after the piston has started moving from BDC towards TDC after some interval, because some interval will be required for the closing of valve. And before the end of compression stage, the combustion is initiated with the help of this spark plug. A high voltage discharge is passed, because of which the combustion process is initiated. So our next stage or next stroke is combustion and expansion. In the combustion stage, the combustion occurs for a very short time, but finite length of time when the piston is near TDC or when the compression stroke was near to end. So slightly before the TDC, we give a high voltage discharge to our working fluid. Because of this discharge, the fuel starts burning and our combustion stage begins. The combustion generally lasts up to the power stroke slightly after TDC. The combustion changes the composition of gas mixture to that of exhaust product, and it further increases the temperature and pressure of the engine cylinder to a peak value. Since all the valves are closed during this stage, the high pressure which is created because of the combustion pushes the piston away from top dead center, and piston now starts moving from top dead center to bottom dead center. This is the movement, or this is the stroke in which we get our useful work output of the engine cycle. As the piston travels from TDC to BDC, the cylinder volume is increased, causing this pressure and temperature to drop. That means the high value of pressure or the peak value of pressure that we are getting, we get it just before the expansion stroke begins. Just before the expansion stroke begins. Then the final stage is our exhaust. Before exhaust, there is a small stage which we also called as exhaust blowdown. What happened? Late in the power stroke, we open our exit valve and exhaust blowdown occur. The pressure and temperature which are inside the engine cylinder are still very high relative to the surrounding point of view, and a pressure differential is created which is open to atmosphere. This differential pressure causes our product of combustion to be pushed out of the cylinder and through the exhaust system when the piston is approaching to BDC. This exhaust gas then carries away a high amount of enthalpy, which may lower the cycle thermal efficiency. Opening the exhaust valve may reduce our work output, but it is required because of finite time which is to be needed for exhaust blowdown. Because without exhaust blowdown, the product of combustion cannot go out of the cylinder, and we need that product of combustion should exit the engine cylinder before the incoming charge takes place. Then finally, our exhaust stroke starts. By the piston reaches BDC, exhaust blowdown is complete, but our cylinder is full of product of combustion or exhaust gases, which are now absolutely at atmospheric pressure since the peak value have already been gone and the pressure have been lowered during this expansion. With the exhaust valve open, now the piston will start moving from bottom dead center to top dead center. This movement of piston pushes away the remaining product of combustion out of the cylinder into the exhaust system at atmospheric pressure, leaving only some portion entrapped between the clearance volume, that is the volume of cylinder when the piston is at TDC. Now, near the end of exhaust stroke, we open our intake valve. We start opening our intake valve. It is so that it is fully opened by the piston reaches TDC, because opening of valve will also take some time. So when piston approaches near TDC, we start opening the intake valve and start closing our exhaust valve. Due to this opening, some of the amount of fresh charge start coming into our engine cylinder. This fresh charge will now push out the remaining product of combustion which are entrapped in the clearance volume. Now, when the piston reaches TDC, the exhaust valve is finally closed and intake valve is opening, and it will completely open after some time. The piston starts moving away from top dead center. During this, one moment may occur in which the intake and exhaust valve Both are simultaneously open. This moment or this particular instant is known as valve overload. So this is how the first stroke or first stages take place in a first stroke SI engine. In the next class, we will discuss about first stroke CI engine. Thank you.